For another briefing. So in this briefing, I wanted to start out by looking at the satellite imagery, seeing what's going on out in the Pacific, and you see there's this small little system right off of the coast of Southern California. I just put I'm just gonna show you where that is here. See right in here, there's that low. See, there's a bit of rotation around here. There's a counterclockwise rotation, which is classic around low pressure centers. It's what the flow around low pressure centers in the northern hemisphere is, counterclockwise. So you see this low out here, and it's a cutoff low. So it's cut off from the main flow of the jet stream. It's just kind of spinning out here, and it's bringing a little bit of moisture and a little bit of lift to Southern California, and then a little moisture, some high clouds, but not much in the way of precipitation for the Bay Area. If we see the radar overlay here, see if there's any rain with that. Not a lot, maybe a little light rain here off of the coast of Southern California, a little bit off of the Bay Area, but it's not really showing much. In terms of precipitation, there's not a lot of moisture with this system, but you can see the spinning low right off of the coast of Southern California. It's very interesting to see that feature there. And I'm just going to take this off and show you here out further offshore. You see our next big system getting ready to make a move. This is going to break this big dome of high pressure that's been sitting over us. This big blob of warm air, this dry air, basically a blocking pattern that has been sending all the storms way to the north. And what we're going to have happen this weekend is that this pattern is finally going to be broken. There's a weather system out here that's going to carve out a trough in the jet stream, and that's going to be able to finally break this ridging pattern that we have. And I'll show you what I mean when we look at the computer model projection here for the GFS model. So what we're looking here is pressure heights at 18,000 feet. And we can clearly see that feature I mentioned, that cutoff low, right here off of the coast of Southern California, right at the bottom of the frame. And then you see, of course, a big ridge. See this ridge in the jet stream. The jet stream, it usually follows, it's usually in between the 540 and the 558 line. But you can see here by the winds, where you have more lines on the wind barbs here, these are stronger winds. The jet stream is roughly about here from this depiction here. So this is a big ridge, and under a ridge we usually have high pressure, except for this cutoff low here. In general, the pressure in these areas here is pretty high. Now offshore we have a low pressure trough. This is like out of frame in this moment. It's probably like over here. But you're gonna see this thing progress as we put this projection into motion. Let's watch this thing as we go into tomorrow. This is tomorrow morning, tomorrow early afternoon, and then this is Sunday morning. See this thing carved, it just blasts down. This is trough. Here's our upper level low. Right in here, 546 decameter low. Sorry, that's not very well drawn. Then you have the trough in the jet stream right here. You can see this clear buckling of the jet stream because we have a big ridge out over the central Pacific, and that is forcing air up here, and it's displacing the cold air that's over here or the Gulf of Alaska, and it's sending it down onto the west coast of the United States. So you see this troughing pattern. You see this thing carves way down into Southern California. Unfortunately, it's not tapping into a lot of moisture, so it's not bringing a lot of precipitation, but it'll bring some precipitation. I'll just put the precipitation view here. You can see some rain, some significant snow for the mountains. It'll be good in terms of producing snow for the mountains. Just chilly rain for lower elevations, but not a lot to speak of. It's not a lot of moisture with the system. And here comes the next system. It's more of an inside slider, as we call. I'm gonna show that. So an inside slider is when, instead of coming from the ocean, the trough is taking more of an inland trajectory. So basically it means that it's doing this instead of doing this. Now the difference with these two is that when it's doing this, when it's coming straight from the ocean, the edge of the trough will be like over here, and so the moisture tap, it's able to tap into more moisture, whatever moisture is available, because of the southwest wind flow from the tropics ahead of the system. However, when the system is coming, I'm going to do this again. When the system is coming more, it's passing to the north and it's taking an inland path, you can see here that the trough, the leading edge of the trough right here, it's not really, by the time it reaches California, the wind flow ahead of it's more out of the west. You can see the wind barbs here out of the west. It's not tapping into as much moisture or much moisture at all for a lot of areas. It's not really tapping into that subtropical moisture, so you don't see a lot of rain when it comes to this kind of setup. However, now, mind you, we're looking far out in the future. When we go past a week or so on these long-range models, the forecast becomes, or the projection becomes less reliable. We shouldn't consider it a forecast at that point because there are a lot of variables that can change in the atmosphere. And every 6 hours, the run will be different when you're looking this far out because the deterministic conditions, as we best understand them, change. So 6 hours from now, the forecast for this specific time frame here on March 6th might be different. Anyways, this is just the signal. Let's not consider this a forecast. Let's consider it a signal. And what we see in terms of the signal for March 10th is another pretty big trough out here, which could have a significant moisture tap with it. And if we look at precipitation, it looks like it has a decent moisture tap, and here's a good little system. However, if we look at the previous run of this model, which is just 6 hours prior, see, this looked a lot stronger on the previous run. So we have the previous run on the right, and the current run is on the left. But look at this, the previous run, 528 decameter low. This is very strong for March, right off of the Pacific Northwest. And then you have a secondary upper low of 534 decameter low, also very strong for this latitude, Northern California, in mid-March. yeah, that's a very strong low. So this was looking a lot stronger and even more impressive on the previous run, and it looks like the flow is even a little more out of the south, which to me would indicate generally more moisture. This looked like a colder, wetter system on the 6Z run. Look at this trough. Look at the 540 decameter line. Look at how low it gets, basically all the way into Central California. And look at this current run. It's not as strong. The 543 decameter low, not 534. That 528 low off of the Pacific Northwest is just gone on this run. You do not see it there. So this is not as significant. This is a weaker trough. The 540 line, mind you, it's. Let me just compare that one again. Look at this. That's where the 540 line is, which is generally also the freezing line at 5,000 feet. So it's a good indicator of where the cold air is bottled up. And look at this. On the previous run, look at how far south this cold air is going. And on this run, so it's way further north. It's like north of Portland. Whereas the previous run, it was all the way into the Bay Area. So even one run to the next, there can be drastic changes. And if we put the precipitation view, let's see here, because, I knew it. So as I was saying, in the previous run, the wind flow was more out of the south over here. So of course, more moisture, you see darker greens, you see heavier precipitation rates. Here it's out of the southwest. It's still pretty moist, but it's less of a moisture tap. So not as dark green, lighter precipitation rates. And so that's how much you can change run to run when you're looking this far out in the forecast. You're looking past 10 days at this point. So, or just about 10 days, but you know what I mean. Anything after 5 to 7 days on a long range model, you're going to see a lot of variation from run to run. So, just to finish this off, I'll give you a little. This is just a short term high resolution model projection for rain tomorrow in the Bay Area. We're looking at light band around 8 p.m. and then scattered showers into Sunday morning, and not much to speak. I mean, scattered showers, potentially even strong at times for Sunday afternoon. Not much to speak of. After that, still too soon to tell what's going to come with the next few systems. But I mean, if you put the precipitation amounts here, maybe the wettest areas in the Bay Area, maybe half an inch, maybe an inch. I mean, the hills, some isolated spots in the hills, maybe over 2 inches. Maybe Tamalpais will get over 2 inches, but you're looking at trace amounts for a lot of areas. Maybe some areas could pick up 1/10 of an inch to half an inch. San Francisco, South Marin will probably be around 1/10 of an inch, what it looks like for this. So just put the blend of models here, which tends to be a more reliable projection. You're looking at across the board 1/10 of an inch, maybe a half to a 3/4 of an inch in the wettest spots. So the national blend of models is actually pretty conservative on this. So I wouldn't expect a lot of rain. It's no major system, no major moisture tap, no. There's not going to be any flood warnings or anything with this. But, you know, maybe we'll get more in the long term, like Southern California could definitely use some more precipitation. So long range models, maybe towards the 10th, 12th, we get something down there, but That's where we really need it, because if you look at the... I'll just finish this off by showing the anomaly here. Projected precipitation anomaly for the next 16 days, like that's where most of the deficit is, I mean, if you look at it right now, well, okay, I can't do that. Alright. Okay, well, we have a big deficit, unfortunately, in California. Areas further north have been more favored by the jet stream. Jet stream's been doing this a lot, which means big ridge, dry over here, wet up here. So that's why we could really use a strong system that comes all the way down here. But we'll have to see how that plays out. Anyways, I wanted to thank you for watching this. I hope you're able to get something out of it, and I'll see you next time.